maybe this will be the best way to do it, and so others can see it also. Okay. Good morning. Today is the 29th, the last day of the second Adar. Tonight is Rosh Chodesh, the first of the month. You'll notice that the first of the month of Nisan, you'll notice that today is the eclipse in the United States, parts of Mexico. The reason for that is obviously because a solar eclipse can only happen, and it makes sense, think about it, only on the first day of the lunar month. The first day is actually tonight, because that's the time when we don't see the moon. The reason we don't see the moon is because it's exactly between us and the sun, except that usually it's lower or higher in the horizon. Usually doesn't even happen during the day, that it passes in front of the sun. There's a lot of reasons why we don't have eclipses every first of every month, but the only time that this can happen is the first day of the lunar month, or the first day of the Jewish month. Correspondingly, the only time you can have a lunar eclipse is on the 15th, the middle of the lunar month, which is when the moon is exactly behind the Earth. It's the only time when we see a full moon. And so, two very interesting facts, very simple. You should think about how things are aligned in space. That a solar eclipse can only happen on the first of the month. A lunar eclipse can only happen when the moon is full on the 15th of the month. It is also the 8th of April. And again, in the civil calendar, there's no rhyme or reason why the eclipse is on the 8th. There's absolutely no connection. But this all works out very well because what we're going to do today is we're going to be doing some math. And so that works out well with the eclipse. I've shared on the screen the article for today, and we're going to be looking at a phrase that is from Leviticus 13:10, and it reads, "It has churned some white hair, v'yafcha se'ar levan." It's talking about a lesion, and the hair inside the lesion is turned into white. We're going to be talking more about the colors of the lesions of tzarat and what they mean during the rest of the week. Today, we're just going to look at this phrase and start analyzing it mathematically. So the value of the entire phrase is 784. 784 is a square number. It's 28 square. Now, how is this related specifically to our year? Our year is 5,784. Tafshin Pei Daled. That's this year. So this is a very good time to look at this phrase, which is equal to 784, 28 squared. And if you read any of our writings, any of Rav Ginsburg's writings about the first, about Rosh Hashanah of this year, 5784, it was a lot about 28 squared. So apart from being an independent phrase grammatically, when the value of a phrase is a square number, that too indicates its inner coherence. So we have that the white hair that grew inside, v'yafcha se'ar levan, is a coherent phrase. Apart from the fact that grammatically it already is, but now numerically it is also. 28 squared is the same thing as saying 2 squared times 14 squared, because 2 squared times 14 squared, like saying you take the indexes, you multiply them, 2 times 14, that's 28, and you retain the square, so that's 28 squared. The average value, but because 2 squared is 4, so the average value of each word in the phrase is 14 squared, or 196. That has to follow, because it means that 784 divided by 4 equals 196. So we have that not only is the whole phrase a square, but each word on average is a square value, 14 squared. Since the total value of the phrase is 28 times 28, which is the same as 28 times 2 times 14, and we have 14 letters. If you read it, well, there are 14 letters here. There's 4 words and 14 letters. So that also means the average value of each letter is 2 times 28, or 56. So let's take a closer look at this product, 2 times 28. 28 is a figurate number. We started talking about these. Figurate numbers are integers that can be drawn using, for instance, small circles or squares, or whatever you like, as a symmetric figure that makes some sense to the eye. So in this case, 28 is what we call a triangle. It's the triangle of 7. And so you would basically have 7 points, 6, 5, 4, 3, 2, 1. It says here, which looks like, but there is no actual picture here. But it's very easy to envision. And if you have 2 times 28, that means you have 2 triangles. So what you do is you arrange them with their bases touching. So you'll have 7, 7 in the middle, then 6, 6, 5, 5, 4, 4, 3, 3, 2, 2, 1, 1. And you can easily imagine that that creates a diamond figure. So the 56, the average value of each letter in the phrase, is the diamond of 7. So that in and of itself is something that we do a lot. What it also means is usually if we would have 56 letters, let's say, so we would organize those letters in the shape of this diamond. And then many things come out of the verse that can't be seen in any other way when you order it based on this figurate number. But in this case, it's not the number of letters. Number of letters is 14. The number of words is 4. So here it's not the shape of the verse. It's just numerically how we're analyzing it. Furthermore, we now have seen that the value of the entire phrase is 28 times 28, whereas the average value of each letter in the phrase is 28 plus 28. That is very rare. So 28 is very important here. The whole phrase is equal to 28 squared, and the average value of each letter in the phrase is 28 plus 28. Okay, let's look at the final letters of this phrase. Let's turn some white hair of the Afchas Levan. They spell Aaron. And this is exactly what we're talking about. The whole parsha, the whole discussion of the Torah is, and we'll talk about it during the rest of the week, why is it that the priest is the one who needs to see it? We'll see this this week, and actually next week even more, because the purification process that the person who had tzarat goes through is discussed in the beginning of next week's Torah portion, Mitzorah. But even here we see already Aaron, his presence is very much felt. And Aaron, as you might remember, the value of his name is 256, or 16 squared. So we had 4 letters that equal 16 squared. The remaining letters, right, these are the final letters, equal Aaron, 256. So the remaining letters are equal to 784 minus 256. Here it says 246 by mistake. Let's correct that. Or 528, which is also a triangular number, specifically the triangle of 32. So we write it by putting a triangle in front of the 32. That's this thing here. Let me make this a little bit bigger. Maybe we'll even be able to see it. But now note that 32 is 2 times 16. So if we're doing the triangle of 32, that's like saying the triangle of 2 times 16. So we have found a very interesting, not entirely trivial mathematical relationship, that 28 squared is equal to 16 squared, which remember is the final letter is Aaron, plus the triangle of 16 plus 16, or 2 times 16. So this is very interesting. The 28 squared, basically what we would do with this, if we would develop this further, is we would create a series of numbers that have this relationship. Meaning we'd ask, first of all, is there any other square that is composed of a square plus the triangle of 2 times the index of that square? And this is a beautiful question to ask mathematically. What is the rule here? What other numbers will fit this relationship? And usually you do something about the relationship between 28 and 16 could be that it's 28 is 4 times 7, 16 is 4 times 4. It could be that it's related to that. And there's something called Pell's theorem in number theory that is a useful theorem that helps find these general rules. Now, there's something more we can say about this, because the value of a triangular number is easily calculated using the definition triangle of n, of any n, let's say 5, is equal to n times n plus 1. So we'd have 5 times 6 divided by 2. 5 times 6 is 30, divided by 2 is 15. So the triangle of 5 is 15. And that's easy to check. You could just do 1, 2, 3, 4, 5. And then 4, that's 9. And then 3, that's 12. Then 2, that's 14. And then 1 more, that's 15. So the triangle of 5 is indeed 15. So if we use this, we have that 28 squared is equal to 16 times 16. That's our 16 squared. Plus 32 times 33, because basically what we're doing here, we're doing the triangle of 32. So we'd put 32 here and 33 here, divided by 2. Or we could just rewrite this as 28 squared equals 16 times 16 plus 16 times 33, because 32 divided by 2 is 16. So now we have this relationship. The 28 squared is equal to 16 times 16 plus 33 in parentheses, which is like saying that it's equal to 16 times 49. But then we could have found this in a different way, but we found it this way. 28 squared is also equal to 4 squared times 7 squared. Before, remember, we had that 28 squared, a little earlier, we said that 28 squared is like 14 squared plus 2 squared. Now we found that 28 squared is equal to 4 squared times 7 squared, or 16 times 49. So that is, so there's a question always, whenever we see these things, this is how you learn math. Is there another triplet of numbers for which this is true? Is there any other such triplet that 28 is equal to 28 squared is equal to 4 squared plus 7 squared? So we already had 14 squared and 2 squared. So we know there's another triplet. So now the question is, this is a much harder question to answer. When is this true? What square numbers have a product of, are themselves a product of 2 square numbers? And you could try to develop this mathematically. What I want to look at, though, at the end here is something a little bit different. And this is taking figure numbers much further. There's one of the techniques that we use in analyzing a text from the Torah is what we call alternating words or letters. So we take the first and then we skip, and then we take the next one and skip one, and so on. This is not the same thing as equidistant skipping, which is something that we're not very fond of for a lot of reasons, because it's been used in a strange way, trying to prove things or whatever. Really, the interest that we have in this is purely mathematical, and sometimes very interesting things come out in terms of learning Torah and understanding it, but it's not used as a proof. So 16, the root value of Aaron, which is 256, like you said, figures even more prominently in this phrase when we consider alternating words. So the sum of the first and third words, if you take the first and third, we skip the second, is 592, which is 16 times 37. So not only are the final letters a multiple of 16, but the first and third words are 16 times 37. And what that also means is that some of the second and fourth words is 192, or 16 times 12. So we, of course, already know that 37 and 12 have to be equal to 49. That's where we got our 7 squared from. So we have 4 squared, which is 16 times 49. So even though that was like just a general statement before, now we see that it's related very particularly to the words in this phrase. This is very uncommon. This is not something that you would expect to find. And when these things happen, we see it as a demonstration of what we call self-reference. It's like the Torah is referring to itself. It builds upon what we already saw. And then you see this as you analyze further, you continue to see these relationships happening in different places. So now we've done that for words. Let's do that for letters. So the sum of the first set of alternating letters is 543, which incidentally is the value of God's connotation. I will be that which I will be. Ekia asher ekia. The sum of the second set of alternating letters has to be 241 because together they're 784. And this is the secret of the acronym Amal. Amal is a very important acronym in Kabbalah. It stands for the three words light, water, and firmament. Or Maim Rakia, the initial letters of these three words, light, water, and firmament, spell Amal, which is equal to 241. This is considered to be, in Rabbi Isaac Luria's Kabbalah, one of the most basic processes. Whenever he talks about the creation of the world, the creation of a child, and remember, we're in Parashat Tazria. We began yesterday with talking about the conception of a child. So this is very fitting here. Mathematically, 241 is the covenant number of 16. I don't recall that we talked about covenant numbers ever, but the place to talk about it is actually the Parsha of Noah. Noah is the first one to have a covenant with God. He actually has two covenants with God, and then Abraham has two covenants with God, and then there's the covenant on the Torah and the covenant of the covenant of the Torah is the one that brings it to 5 covenants that we talk about in the Pentateuch, which is another reason it's called the Pentateuch. It's related to the number 5 because there are 5 different covenants that were made in this book, in these 5 books. So we're not going to get into what these look like at the moment. And actually, we're out of time. But if you look at the article, you'll see how we take these alternating skips and we build what we call a finite differences series. This is a Newtonian technique that is like doing calculus for discrete numbers, for whole integers, for discrete functions. And then we come up with something really beautiful that comes out of this verse, which is, I hope you can see these here. I'll try to make them a little bit bigger, what we call octahedral numbers. These are considered to be perfect solids, one of the 5 types of perfect solids. We can't get into them right now because we're out of time, but this also comes out of these 4 words in a beautiful way. And whenever we have these deep excursions into number theory, we like to also connect everything back to the way that number theory is done today. And so we have here a very, may seem very trivial to some people or actually technical, and who cares, but all these series that we've referred to, they actually are used in number theory. There is a whole area of number theory called figure-eight numbers, and there's a whole encyclopedia of figure-eight numbers called the Online Encyclopedia of Integer Sequences. It's about as geeky as you can get. If you're not into mathematics, this is diving off the deep end here. And each one of these series is cataloged, and not just cataloged, but all the different attributes and functionality of each one of these series. All of these series are very useful, actually. You can do things with them. So here we have that series called triangular numbers, or a sequence called A000217. Square numbers are 290, and so on. The diamond numbers are usually called pranic numbers for some reason. And there are another covenant numbers do not have an exact representation in the Online Encyclopedia of Integer Sequences for some reason, even though they're very simple. They come out of a very simple function, which is n squared plus n plus 1. For some reason, it's not documented there. Somebody who understands about this could actually add them. I think in the past I tried to, but I'm not a professor in a university or something like that, so I don't think they accepted the addition. Thanks for joining today. Go out and enjoy the eclipse. And if you have time, there was a class that I'd very much recommend that you hear about the meaning of the eclipse in terms of understanding the relationship between us as human beings, the Jewish people, and God. and also the relationship between husband and wife. I'll try to put the link to that class in the first comment or maybe in the description of this video on YouTube. And I think it's very pertinent to hear that class. I think it was a tremendous breakthrough. Another thing I'd like to do a little plug for today, since we have been taking a lot longer than usual. A friend of mine, after a couple of months of research, put together a book on the eclipse. Has a lot of very interesting ideas, um, and I'll put a link to that book. It's a free PDF that you can download, and it makes for very interesting reading for today, because we don't see these things as omens, but we definitely are impressed and take note and try to learn something from everything that happens around us, including everything that happens in the natural world. With that, thank you very much for joining. Hope to see you tomorrow.